Hello, everyone. Welcome on behalf of .NET Foundation and Belabit user group. So Belabit is actually one small user group from Banja Luka, Bosnia and Herzegovina. We have more or less regular meetups, mostly regarding Microsoft technologies. And yeah, we have some interesting guests here and then. Usually we do these sessions live, but of course, the situation is how it is at the moment. So yeah, we'll have an online session now. And with us, we have our friend Ratko from Croatia, and he is going to talk about microservices and containerization. And also, we have two licenses, two coupon codes for JetBrains products, and anyone that wants to get the license can comment on our meetup link that I have posted on the YouTube chat. So just go there to our event and post a comment if you're interested and want to ask some question to Ratko, etc. So without further ado, let's just go through a few slides. So we are doing this in cooperation with .NET Foundation, virtual user group, and yeah, .NET Foundation has provided us with this stream and all the technical help needed for this. And you can join, you can follow other events. There are many events currently, and most of them are online. And at the end, yeah, this is the link to our group. So without further ado, Ratko, please take over.
So thank you, Miroslav. Thank you, Jelena, for this kind introduction. Yes, why not? Let's begin. So my name is Ratko Cosic. I work for Ekobit as a software developer and software engineer, senior, and software architect. And today I will speak about microservices and containerization. And I thought about how to present it because there are a lot of topics today to cover. But just in a nutshell, it will be an introduction to building so-called cloud-native applications. Just one remark. Maybe I'm famous for the memes, but today, so no memes today, guys. So sorry about that. There are a lot of things to cover. Yes, so the first thing is why and what is the cloud native application? What are the cloud native applications? In a short definition, their applications are the one that are based upon the containerized infrastructure, an architecture that is built around the microservices paradigm, and they use continuous integration and delivery of the applications. Of course, cloud native technologies are used for building these kind of applications built upon the services packaged in containers, deployed as microservices, and managed on so-called elastic infrastructure throughout the agile DevOps services. Also, one disclaimer, I will show you more or less a Microsoft way for doing that, but it's of course it's applied to other vendors as well. So what we should cover today, once again, a lot of things. So, but let's consider that as an introductory level. We will tackle what is Docker, what are the containers. We will see some of the development tools for containerization at your disposal. We'll see how differ monolithic to the microservices approach to containerization, give a little bit intro Kubernetes, that is definitely quite famous, And later on, we will move to the DevOps workflow, and I will present you some of the things you can use on the Azure. Of course, it will be ended by some additional things, and yes, I will be open for questions. So let's begin. This is, let's say, a canonical picture about what we have as a Docker, if we use the Docker provider to be that one application be containerized. Of course, we could use some other things like Windows container, but Docker is, of course, the most popular. Docker is open source project. It's definitely use some of other paradigms that virtual machines and Hyper-V, etc. I will not go into the details, but probably you've heard that it's Docker and containerization has a lot of benefits that allows us to build and develop applications in isolated manner, in containerization manner, regardless of the operating system we use, albeit Windows, Linux, or Mac OS. And in Docker, the host has everything that is needed, including the infrastructure and the OS, and the container engine actually keeps these containers isolated, but they share the same base infrastructure and operating system, kernel, etc., etc. So the first thing, and the first term is container. What is the container? Container is actually a package with all of these things that that application is built. It includes dependencies, such as frameworks, plus deployment and configuration to be used in container in runtime. And the image is actually already pre-built with the operating system, with the environment, etc. That we could build, and it's usually built upon and pulled from the registry. And you can see here are a lot of registry available, both on premises and on cloud. Of course, we will concentrate on the cloud. And the most used, at least on our sense, is Docker Hub registry that is publicly available, and also Azure Container Registry that is available on Azure. And the first thing that we will cover is, of course, a very simplistic, so the most simplistic way to containerize the application that we did it before with the monoliths, and that is actually creating the container from the image and put it on the host. So definitely that approach has a lot of benefits because it's benefits that differs between using the application like it is in the process, because it uses a scaling mechanism. We can scale the instances of container very easily, far faster than and easier than the traditional VMs or services that we will build upon. And everything else, so deploying the updates in the Docker images are far faster and efficient, and etc. And as we will take a look on shortly, although the monolithic apps have benefits from Docker, here we are touching only the tips of the benefits. And yes, but we have to start with something. So let's begin with something. I will show you what you can have and use on your desktop to create and start with the Docker. So what I'm now having, I don't know if you see my fonts, and I'm using Visual Studio Code just for the terminal sake for now. And I have the installed Docker desktop application, so Docker is installed there. Another version, and I'm just reading the Docker and using it with the Docker CLI. First, I will see what is what containers I have. You can see I don't have any containers except the system one, so just regard always these two. So nothing's there, but you can see how easily I can actually run some container. Let's say I will run one exemplary container that is available from Docker Hub that is just testing whether we have everything installed. So it's run, everything run. Okay, we didn't see anything yet, but let's pull the image from the Docker Hub, so it's published registry with some exemplary code. So I will use Docker run command that will run the container for me. I will use my ports. You will see shortly why it is important. For now, just pay attention. I will just use 3000 port, external port, and I will just see the image that I will pull from the Docker Hub that has some, let's say, content. Okay, and nothing happens. Okay, let's see what we can do and what we can see from the Docker UI. Hopefully we will trigger that. Yes, you can see here I'm running the Docker Windows, and you can see that I'm started before this hello world container, so it's gone, it's not active, but this is active because I've just run it. And what is great that I can control it and just click in there and see the logs for that. I can inspect the environment, see some stats, how many. So I don't use anything, but yet because it's very simplistic way. I can also see it in the browser. So let's see it. Sorry. So that's one just page that that shows the hello world and my host name, my ID of the container, and that's it, more or less. Okay, what I can do now, I can just stop it, and okay, let's see the containers once again. Okay, and you can see I'm having one run already. I will just try to wipe it out from the Docker by just providing the ID. And when I refresh the window, you can assume what will happen. So no, nothing is there. So that actually presents the way the Docker is handling containers. So it's totally isolated environment, and it's run when it's run. So it's everything there packed. Okay, just let's try a little bit more. What I could do, I could also run some other images from the same container. I will just provide another port and provide the command that is actually detached, so I don't want to be blocked there. Okay, and sorry about that. Missed the parameters there. I will also run another one and run another one. Okay, and let's see our Windows Docker. And you can see we have 3 containers, each actually originated from the same image. So we can also browse it and yes, see once again that each of that containers really works. So, and of course, if we kill it, we will just kill everything. So all the processes. And that's okay for now. I could also kill the images there, just to make myself tidy. I'm using a lot of things on the local. Okay. So yes, that's the command line. Nothing cool about that, really. Let's see what we have for the tools of productivity there. I will use Visual Studio 12 19 and create a new project. Just create a new project. from a glance, from scratch, and I will choose one of the templates. Yeah. It's a little bit slow there. Sorry about that. Okay. Okay, I will just put some name there. And what is important to see is this option is the enabling of Docker support. Of course, I have to have it installed Docker desktop, as I pointed out. I will choose the container. Let's say it's Linux, and that's it. So we will create a project in Visual Studio. Let's see how it looks like, and we will see what will we have with increased productivity for using the Docker. Okay. 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 The first thing what I'm actually very fond of is this introductory page that you can see the important links and docus for the using of the Docker inside the .NET Core. That's cool. And yes, you can also see here, I don't know if this is viewable by you, it's maybe too small, but something is going on in the background. So we will see what is going on. Okay, so the Visual Studio for us adds one special file. It's called Docker file that actually specify the manifest or the way Docker will build our image from. So to build our container. So we've seen our one Hello World example that is pre-built, but of course we want to build our own application. And these are the instructions that Docker will use to build our image. So it will use some pre-existing image to build upon. This is the ASP.NET 3.1 multi-arc. So that runs in different environments, and then it will try to restore our .NET application, build it, publish it, and make it final. So make it published, and the thing that will finish with it is it will expose 2 ports for accessing the Docker image. Okay, so that's it, and actually that's automatically built for us when we actually create or rebuild the solution. So it's automatically built, and you can see here that this default startup is changed from the IS Express to Docker, and if we click on it, so we'll start the Docker container. So let's see what is happening here. So Visual Studio already done this job. Okay, and we will start that. You see the red and then the green one. It is running, and it will soon open the browser for us as always. So nothing new, but it's already running. This container is already running. It's kind of slow on my side. Sorry about that. And also, it's an interesting thing that we can see. So here it is, nothing special, just hello world for now. That the container of our application is working, and we can also see other containers as well, and also with all the images that are provided by us and be pulled from before. I pulled a lot of stuff, as you can see, and also by the origin, for example, from the Docker Hub, from the Microsoft, for my ACR, or something like that. So that's about it. Okay, let's do the more things about our containers. More or less, what I presented is really a small example that we could run the containers from either the command line or Visual Studio. And the question arises that, okay, we are just running one container. And if you want to scale or do something about our monolith, Before we could just, copy as we did before, just create a lot of containers that are actually all the same, based on the same image, just contained in one host. Host actually holds all the containers together. In more, let's say, advanced scenario, we could use some load balancing that will allow us that actually we split the calls or relieve the requests for our typically ASP.NET or web server, that one instance is not, not in a lot of load pressure, but it's still, as you can see on the container, still one image, still one monolithic application. This is the one that we could already have with the VM scale sets, with the typical deployment in the Azure App Services, because they are they could run a monolithic application, and they easily can create instances without having to manage VMs. So there we have already some kind of advancement to the just provisioning so fixing provisioning of the instances of our services. Yes, in a more, let's say, microservices approach, there are a lot of changes. As you can see from the diagram here on the left side, a traditional monolith has everything in one container, and that's about it. So we just can scale by the cloning of the app to multiple VMs, multiple containers, and that's it. Scaling is actually like in the microservice architecture, that is benefit is actually we don't have any scaling except that we have to put everything, deploy everything on the one host, and that's it. So we don't have any other things around. For the microservices application approach, every microservice is actually contained in one container, but it also have to deploy everything around this microservice. So, and also these hosts in this case will be different. So we will think about the host that will contain one microservice, typically with other containers as well. For example, if you have some database that will be contained because this is domain database, or the message broker like RabbitMQ or Service Bus like, or we have some kind of blob storage, Redis cache, or some other stuff that are actually quite necessary to be installed and deployed together alongside with the microservice as a sidecar. We have to have it on the one host, but we will have a different host. So definitely need approach from other perspective as well. So let's go forward and see what actually Visual Studio can also offer us in that sense. I will now shut down our Docker, just see what's going on there. Also one neat thing, when I close my Visual Studio, it will eventually, kill the process, and everything is clear. That's love about about the Visual Studio and how it manages the processes and Docker containers. It's great. So once again, I'm opening the Visual Studio. I'm opening now my simple solution. It's really rather simple. I didn't go into detail to providing the fully fledged microservice architecture, but just imagine what it could have, and it will be architect. The most parts for containers will be presented. You will be introduced shortly. So let's pretend this is a very, very big application, not just like that. Oh, it has Docker files, so nothing special about it. It's more or less the same that we've seen before. So it's building, so restoring, building, and publishing thing. So our container we already have. But yes, this is the microservices. So we also have to have a way to link and build other containers that are necessary for our microservices as well. And actually, I've done it throughout the Docker Compose. And that is the another option that we could pick. Uh, Unfortunately, it's not seen there because I already picked one. You can only see the another one that I didn't pick. That is Helm and Kubernetes combination. There is also one another, and that I actually picked, and that is called Docker Compose. Docker Compose actually it's still Docker functionality, and it actually compose the Docker images and put it in the containers that are actually hosted in one physical unit, and that is called the host. So this host actually, as a group of containers, pack it all together and provide it, run it in one isolated environment, and that is neat for microservices, definitely. A Visual Studio that I don't go, manual everything. I just use Visual Studio. Actually creates herself this special folder and presents us with the Docker Compose YAML. I don't know about the YAML. It's used widely, I think, in Azure DevOps or other things in business application because it's very human readable. And I don't know if you see that. And actually, it's also manifest, but now we are talking about multiple containers, so multiple images that will be built and then upon instances as containers. And first one that we already seen is our application. So our application is presented with a name. It has an image that is built upon, and that is actually the Docker file builds this image for us. This is the Docker file that builds it. It has some context, that is the folder of our service. And it will build the image, tag it for us, but it also, on addition, has dependencies on other containers that I actually built from the pre-built images found on Docker Hub. So it's publicly available. I'm using the Azurite here. Azurite is a great tool for simulating the Azure storage. It has a lot, it has limited functionality, but I'm using blob storage, so it has it. So it will build our, let's say, a small storage container for us in an image. It also uses the Cosmos DB, Azure Cosmos DB, but for the container, we will use it as lightweight MongoDB installation on the Linux. And also we are using in an event-driven paradigm. So in the event bus paradigm, we are using message brokers for communication throughout our microservices. And we are using, of course, in the enterprise grade Azure Service Bus, but for the containers locally, we just can use some other message broker like RabbitMQ. So that's about it. And if you pay attention to these small ones, that is something is building, something fish is going around there that I'm talking between. So actually, you can see that Visual Studio in the background runs the Docker Compose command and provides this YAML file for us, and also another YAML file that is actually the configuration, as we can have our standard app settings configuration per environment, let's say development, QA, testing stages. We also can have the environments so set throughout the environment. So I have this on development, that's the default one, the override, and I have this my environment. I will not present you with the whole key. That's the key that they are using, but with the ports open for this container. So without further ado, let's run it and let's see what is happening on the Docker Windows. Okay, build is succeeded, and we will also be presented shortly with the browser, and that will actually trigger our web API. Here it is. So that's our application, basically. But what is interesting that this is not the container. This is just the host that is marked with the ID. And if we expand it, we will see 4 containers there, all running separately, but bound together with the composing. And yes, we can see it in action. So as I see it here, it's running. That one, I also can see the Mongo. Okay, that's running, but I just cannot access it through the HTTP, so it's okay. And let's see, for example, Rabbit. You can see it's running. So it's Rabbit MQ server running on the container. So we can play around with it. Of course, configure it to the development that the ports are visible, and you can see the ports there. It's configured on this compose file. And our microservice actually works on a development machine. So let's, yes, also one thing that's maybe kind of neat is Visual Studio. We don't need to always open the Docker windows. It doesn't need to be. We can also see solution containers and all other containers that are coupled with our containers, with our running container. And for example, for Rabbit, we can see the settings that it has. It has seen the open ports, as we can see, 15,000. Also the logs, and especially the files. So this is actually the files in the file system. For example, if you can see on our application that's installed in the Linux environment, and you can see the whole things around there in the source folder. We can stop it, and let's see what is going on our Docker. In the meantime, if everything goes fine, for a couple of minutes, it will just make it disabled. So shut it down and it's gone. And of course, if we try to run it, it will not work because we shut down our containers. So what does it mean in terms of deployment? You could foresee how we will use these containers, so our images and containers later on, and to deploy that in some environment. We could use a simple Docker host environment with the Docker Compose task on our DevOps to effectively deploy everything. So this host that I showed you on different stages, and that is simplistic way for doing that. There is no harm done to do that. For some simple scenarios, it will be sufficient. But of course, for some other scenarios, like that, we have orchestrating of the microservices in more quality sense, it will not suffice. And yes, we are going now on the orchestration, because orchestration is something that is far more sorry about that, rather than just putting all together these containers, in a set, in one host. Because for the microservices especially, we want to have a control what is going on with the life cycle of our containers, because we want to offer something like handling the scalability, handling the failover, and restarting the services when everything is wrong, making the health check. So what is called observability of our services. For doing that, to make it happen, we have to have some kind of orchestration and someone that will control us in the way that we do. And yes, one of the things we will definitely have to cover today is Kubernetes. So Kubernetes is open source technology for automating our deployment, for scaling, for management of containerized application. It's actually started in 12 and 15, and in these 4 or 5 years, it's gaining traction. Definitely, I think it has a lot of community support, and I think one of the largest community support on the GitHub. And because of its nature, it's definitely necessary, needed for our scenarios on the cloud native applications. I will not go into the very very deep understanding of the Kubernetes. What is important for today, for now, is to cover is that we have some kind of terminology in stake and how it works. So it has so-called Kubernetes cluster that actually consists of set of working machines that are called nodes. Nodes are the things that actually lifts the pods, and the pods are the worker nodes. The components and the unit of the deployment. Let's say deployment unit. Pods actually contains container, and that is the most important unit for the deployment. And the control plane, so the control node, actually controls every other nodes that are called worker nodes. So actually it spawns nodes and control them, and we can we can control it by the command line tool called kubectl. And we can control it with the dashboard, and everything about the management of the nodes is done from the control plane. Pods are basic unit deployment. As I said, it could consist of more of the containers. It's practice that is one. They actually share the IP address that is shared among them, and storage volumes. Deployment is also the thing maybe to understand. Deployment is like in YAML, something that is as a menace with the description of the deployment itself. And the service is also very important to distinguish it. The service is something that we will use or the clients will use from the outside. It has a static network location. It has its ports, so exposed ports, and it also acts like a load balancer. So it actually goes through the nodes and picks the ones that is needed, etc. So it acts like something like API gateway pattern, if you're familiar with the microservices patterns. So I know it's kind of tricky to present it in one slide, but this is the basics of the Kubernetes. So there have a controller plane that will use to see the nodes and to initialize them, and then the nodes will be spawned on our Kubernetes cluster, and each node will contain a number of pods that will be then orchestrated. Okay, let's see something in action, and let's switch back to our command line once again. Let's play around once again, and let's see first how could we use the Kubernetes. And yes, before that, I'm having the Kubernetes here locally because luckily Docker has the option, the feature from the newest versions to enable the Kubernetes locally in the development machine. That's kind of great, because we could have we could use some other tool like Minikube or etc. But I think it's practical that we use Kubernetes outside the Docker. And what it actually does, it's actually Kubernetes in the Docker, more or less. It packs the containers together in the node. It's one node environment, but it can orchestrate our containers. So let's see it in action. So we'll use mostly kubectl command line, that's Kubernetes CLI, and let's first trigger some commands just to see our environment and environment and what is going on in our local Kubernetes. We can see we have two contexts. One is the default one. This is more or less, we can have it more or that, or something like namespace in the orchestrator. We will just use the default one. Just to see what we have. So let's see, do we have some nodes? Okay, we don't have anything except the master. So we have also, let's see the deployments. Okay, nothing there. So we have the, let's see, the services. Okay, nothing but the system ones. So pods, okay, so nothing there. So we are clear. Okay, and okay, let's see how we will build upon one very simple Kubernetes environment. I will use now this one. This is really small one to present you the structure of our Kubernetes manifest file that is called that is also YAML file like the Docker ones, but it's quite different because it has a different syntax. First one that you will discover, it has some blocks that has some kind of no pun intended. So in the kind is the type of the container that we'll build. So the service and deployment, let's switch to the, sorry, I will try to switch back to this picture that you know. So the load balancer is the service, that is the service node, and the worker node is the deployment. So this will be the deployment. Okay. So the service is something outside, and it has different ports there. Why is different ports? Because pods also can communicate with each other, as you can see from the Docker Compose before. So containers also can communicate internally. So also the deployments, so the nodes could communicate with each other. And also, what is more important for us, of course, for the load balancing, is how we will access it outside the cluster. So, for example, inside the pod, it will be communicate with the 80 port, then inside the cluster with 8080, and 30,001 will be our outside port for my service. And that's just the service, and it will select, and that is some kind like a query, let's say, that will see what is going on, sorry, that will actually pick the right deployment for us to route the calls. And this is our simple deployment. It has some version, it has some name, and that's kind of important information here. And there are these are replicas. So that is actually how many pods we will spawn on our node to be resilient. So we could just spawn, as we seen from before. We used 3 Docker containers that are all the same. So why we don't use it here? Okay. And that's it. So we will label it somewhere, and also this one. So we need, of course, the image to build upon. So this image is also available to the Docker Hub. So I will just use this one. Sorry about that. Switch. I will just use this one to building our first Kubernetes deployment. How will I do that? I will create the deployment with this file, hello deployment. Okay. And you can see the service is created, the deployment is created. So let's see our services. Okay, we have one, it's called Hello World service. We have deployment, it's called Hello World. But you can see here we have 3 ready pods. So let's see that pod somewhere. Second. Okay, so there are 3 pods available. So what could we do? We could play around with that. Luckily, we have a Kubernetes dashboard available. It's there. Only we have to serve it, and let's see it. It's there somewhere. I have to authenticate to my local one, and I will just, okay, it has some quirks, you know, but it works. Physically, technically it works. So from the dashboard of the Kubernetes, you can see here, it's local one. We have one service, and this service, we can also click on that or click on the pods. It's the same. And here we have the information about our service that acts like a load balancer. And this is the most important one, the external endpoints to which we actually will access all of our containers from there. And here are the pods. So let's see that. And you can see here, we are having our pods ready. This is one of the pods that is actually spawned. And that is the nice part of that. It's, sorry about that. I also already switched to my slides once again. I don't know why it's happening. Sorry about that. Just a second. And yes, let's play around. Let's try to try and see and pay attention to this number. So this is the number, the GUI about the pods, and this number will eventually change. It's now F8, F8. Okay, doesn't change. Sorry, I want to produce something. But you have to trust me on that. Yes, you can see it. It's changed. Why it's changed? Because it's really load balancing. So you know, it came from the F8, and we just trigger a lot of requests in 1 second, and service actually started. So route the calls to other pods. So that's actually what the orchestration is all about. Once of the time, one of the things that is running. Okay, okay, what we could do now, and let's spawn a lot of that. Let's do not concentrate just on the 3 ones. We are not satisfied with that, and we will just apply a new deployment. Okay, let's see it in action. What will our service say? Okay, you have now 7 pods. How many seconds it will pass? I don't know. I think in a second we just spawn a couple of pods more. But what we could do, we could just delete the pod. But what is happening? Actually, the container and service, the container, the Kubernetes actually doesn't allow us that we don't have 7 replicas. We will have 6, but it's actually automating to creating one more, that the whole number is 7. So every time there are 7 pods, and that's kind of cool. Okay, and we will just change it to 1. Let's wipe it out a little bit, and just let's see it, how much time it uses. You know, it's just creating, removing that, and yes, it's done. So it's gone. Okay, so that's it. Let's see our deployments. I will just see it because I want to wipe it out. Okay, just let's wipe it out. Sorry for that. Okay, Let's see our services. Okay, I can delete it as well, but you got the point. Okay, so what we could also do, we could also use our persistent image to build upon one another thing, and that's actually our cat microservices. That's our own service. So let's see this in action. This is a similar deployment to this one, but the main reason that I want to show you is that we actually pre-build it and pull it on the, I will not do that because it takes some time for doing that, but it's actually pulled on the Docker. And let's see it where it is. It's on the, I have it somewhere. Sorry. So let's see it. This is my account on the Docker. And yes, this is the one. And I've created and pulled the image that I built on the Docker by using Visual Studio. And it's there in stack, and it is tagged with v1.0. So it's available there. So I can just use that image to build upon my deployment routine. So everything is the same or similar. I will just point from my Docker Hub image. So what is important in that state to know, we have to have some registry, as I pointed out before, like Docker Hub or Azure Container Registry on the Azure, where we put the images that we can reuse also on the local development. So I will just see whether I'm logged. Just wait a little bit about that. Okay. I hope I will. Okay, I'm logged in. So I will just tag my image because it's important in this. Say I have to know about the version, and that is also the good thing, and definitely one of the things also in the microservices architecture that we have to take care about is the version, of course, and how all of this collect together. So I'm tagging that. Yes, I can show you the images. Let's see that. How many I have? Do I have it? I should have it already. Or if I don't have it, no matter, I will just push it. So I will just push the image there. Okay. Cat microservices, services called. Okay, and this is, yes, I'm pushing the image. Maybe I will use our local, I mean, I already push it. It has a cache, so it will not last so long. So I will just, now I have everything now prepared. I will just create another deployment. It's called, I'm calling it local deployment. YAML file. Okay, and yes, the service and deployments are created. So let's see that. Let's see that here. I will close that one and see our services here, and you can see it's there. Why it's this time? It's progressing because it takes some time to Kubernetes to build this infrastructure, to pull the image by itself, by make it construction both of the deployment pod and the services. And if this everything is done, we will get the external endpoint. Okay, it's still doing. I will just delete this one. Maybe it has conflict or something like that. And let's await that it's finished. Let's see the pods. It's there. It's there. They're already there. We're just waiting for the service to be there. Oh, it's there. So you can see it came with the external endpoints, and yes, it's here. So actually, what we built actually the container, our microservices locally on the Kubernetes service. Okay. So enough with the local stuff. Let's base now our talks, our discussion about the deployment process. And this is the, let's say, canonical inner outer loop workflow for the DevOps process in Azure by Microsoft. So what we will use in this blue box, we actually now passed, and that is the combination of the Visual Studio or code with the local AKS dev cluster. Just to mention, we also can use Docker with Kubernetes, but not with the Docker Hub. We can use it with the Azure Container Registry. So we could also prepare everything as much as we can to make this migration fit to the DevOps pipeline. So in the inner loop, we do the things as I now presented, and when we are tested and debug everything and everything is done, we actually push the code on the GitHub, more or less Git flow, something like that, and we are entering on the CI/CD process. So we develop and test Kubernetes definitely easy with this local manner, but definitely we have to deploy it somewhere that customer needs it. So firstly, we will build the pipelines, but then we will include the building of the images, pushing and everything on the container, on the ACR, and this will be used something similar. I hope you use already Azure DevOps and something similar techniques to actually build the artifacts or NuGet packages or feeds or something like that. That will be important and necessary to be used on the release pipelines as well. So when we are done with the build, we will produce some artifacts that actually will be stored in Azure in container registry, and then release pipeline will pick this up and then deploy it on the AKS. Yes, we could deploy it on the AKS, but also on the interim, we could just deploy it on the provisioned resources. That is also the option, maybe a simplest one for the migration. That's maybe easiest way. Okay, let's see this outer loop, so the larger scope of our discussion that includes the CI/CD and the ACR. So let's switch to my okay, DevOps. So this is the DevOps for just exemplary DevOps. It has some pipelines. I will just show you a number of pipelines, just you see some differences. This is just, let's say, a simple traditional pipeline that will actually, it's .NET Core project, web app that will just be restored, built, and run test, published, and then we have a publish artifact as a build artifact that are available to our pipelines. So nothing special about it. We already done that, and for example, we can see that I have only one stage for this purpose, just to test it. And if you can see on the pipeline, the release actually is triggered by the building of the build pipeline, and then the test stage runs with the app service deployed. That's kind of, let's say, standard way that is deployed. What we could do with the containers is the first approach that I showed you before is building the Docker image. So we also have a special Azure DevOps task for doing that. So it's Docker, of course. We can use the build images, and then we already then specify the container where we will put it. So we will put on the Azure Container Registry on this subscription, and we will specify the resource on the Azure, actually the container registry itself. And we will build the image with the Docker file. We will also push it more or less the same here, and we could also publish some other information. I will show you all next. The corresponding release that will be attached to this build pipeline will be release pipeline that will not trigger in the building the artifacts, but it will rather build on the Azure Container Repository. So whenever we build the new container for the ACR, it will be triggered, and then for the latest version only, and then we will proceed with the deployment. And it's already also here provisioning on the exact provision resources, and that is Azure App Service. So as I said, it could be deployed on the Kubernetes, but also we could use as an interim step, and actually we are using that approach because, as you know, microservices approach architecture is anyway evolutionary step. There are evolving a lot of things around, so it's not an easy way to migrate to all of these concepts. So we are using firstly containers as introduction, and then put everything on the ACR, and then still deploy it on the resources that we fixed have, and then move to the Kubernetes. That's maybe more less steep path to do that. And the next also thing that we could use, one variant of the build, just to show you, is to build upon. Sorry, the wrong one. To build the images by using the Docker Compose. So that's the difference between the first exemplary application that we just have one Docker file, so one container, and the microservices that actually has a different containers. And here also we are pushing everything we have on the ACR, but with providing the Docker Compose YAML, and then push everything on the ACR. So that's the way we are. I'm just presenting you. The another thing I want to show you is my Azure portal. Probably definitely are familiar with it. And let's cover some things that we have for the containerization in Azure. The first thing that I'm mentioning now lately is the container registry. Container registry is something like the registry of our images, pre-built images. Let's something like, it's not NuGet packaging or NuGet Olympian server, but it's now, but for containers, let's say. It's just registry, so the placeholder that we put all the containers there. It's of course on the one resource group, and also what is important is how to access it. And this access information is important when we are using Docker on a local machine, for example, to grab that, to pull these images to us for testing on local Kubernetes, for example. And what we can see here is the repositories. So I built 1 and 2, so also this Hello World, of course, but I built one difference. First is throughout the container, and the second is through the Docker Compose. So both of them are actually container images, and you can see there are a lot of versions there, and I can just fetch, so pull the latest, and I will go to the latest code. But we also have here a versioning and version information, where it is built, etc., etc. What is also good in this sense, and I find it also useful, it's already deployed in the ACR, but we also have one layer that is maybe very practical to use to test our services, whether it's working. And that is actually container instances. Container instances is nothing more than when we grab the image and create something like that we create some provision resource like app service or function or something like that. So we can actually trigger from the container registry one of the repositories and just say, okay, I have to find where I can instance the container, and it will create this instance for us, you know, and we can just use it and we can say it, how it is look like, how it is constructed. It has an operating system type. It has where it is gone, where it is belongs to, which containers is actually there, what is happened, so like activity logs, etc., etc. And you can connect it by Kudu or something like that. But that's great thing about that. You see this link, you can see that and go through the link. Just a second, where? I have to find it out. But I think I can just copy that image, that URL there. And it should work, actually. Maybe it should have some time to run it. Or I just missed something, just a second, I didn't provide. Maybe it's HTTPS, but no matter. It should bring some page with the hello world. Okay, so that's neat for the testing purposes. Okay, so let's go more about that process, and that is of course AKS. AKS is definitely the solution for deploying our microservices to the Azure by using the paradigm that we already covered today. Here it is presented one of the workflow that we could use. We already passed through some of the points. For example, we are using the Visual Studio or code to push the code through the source code provider, and then control, and then trigger the DevOps operation that actually triggers our images into the Azure Container Registry. And then we could continue, and that is the new stuff here, continue to provision the service into the cluster. And how it is done, we saw on the Docker Windows in the local machine. The similar principle is there. So it's provision on the pod. It's controlled by the service. It also could be accessed by the admin through the portal. It also has a security to secure the access to the resources. It also could, so the pods and the nodes could also access the provisioned resources. That is quite also, let's say, familiar with the process, because the difference between the development stage and testing stage and the production would be probably on the way that the resources are provisioned and taken care of. For example, we were using RabbitMQ or Azurite, but definitely on the Azure, on some production, we will not use them. We will use maybe Azure Rabbit, but we will use maybe rather Azure Service Bus because it's enterprise level grade. We will use Cosmos DB that scales on the geo location, etc., etc. So we will use other approaches and quality of services that are not necessary, but necessary on the dev test subscription, but it's needed on the production. And of course, administrator should always be in control to monitor the way through the different ways that and things that we have offered have been offered to use on the Azure. That is one of the slides of the Microsoft Ignites compliments to the Microsoft, definitely. But it's a great slide. And it actually explains what we are now having in microservice plus Kubernetes or containerization offering on the Azure. We have Visual Studio and our source control, plus the Azure Container Registry and monitoring on the tools. We have a lot of platform resource ready for us, like security for the AD policy, key vaults that will sure use for our passwords, etc. But the center part is for sure Kubernetes service, container instances, and other stuff that makes the orchestration available and possible. There are a lot of efforts on the community. We will maybe enlist some of that later on. And the latest thing, sorry, maybe I'm too exhausting today, just a few minutes more. I will just quickly show you the Kubernetes services. It's actually presented as I presented before with the term of the cluster. So everything is actually here implemented as a Kubernetes service, as a cluster here. And that is great that we have here options now on preview, but I hope it will just grow and be expanded to graphically see the things around the Kubernetes. First thing, we have a namespaces, just like we have a context on the Kubernetes locally. The default is the one that we will use, or other that we want to create for us, separate ones. We have also workloads. I already provisioned that by my DevOps. I forgot to mention that. So this Compose and the Docker, I actually built on the latest, the last pipeline, release pipeline that I want to show you, and that is Kubernetes. And how it actually came to the AKS, that's maybe more important than the dealing with the picture. As you can see, I'm using both Azure Container Repository here that actually triggers that release, like before, but also I have used the build artifacts in combination to provide me with a manifest file or other file resources that are necessary for building the image. And then I'm using that command of the kubectl, so it's also a special Azure DevOps task that is available for using for the Kubernetes. And I just trigger the apply. So I just apply as I did on the command line, if you remember, and provide the Kubernetes service connection. It's all secured through the Azure DevOps, of course. And I just trigger the apply with the manifest file that I provided with the build artifact. And that's it. So it actually builds. So as a result of this process, it actually built our Kubernetes deployment. Let's see that, maybe have some details there. You can see it uses the kubectl and then uses the apply and applies this lengthy YAML, and yes, it finished. So let's see that and where it is. This is the one, so cat service deployment. And we also can see our load balancers, so the services. And here we can see, you can see the CAT service, that is the service that is load balancing. It's okay, it's healthy. And it has the external IP address that we can browse and see it, how it looks like. I don't know if I'll, oh, it's here. So we can see it in action. So, and if we can want to play around with it as we did it before, we could drop the pod and try to spoil everything, and the load balancing or Kubernetes will take care of that. We could also scale up, scale down, also with the DevOps special tasks that are provided with that, etc. So a lot of options to scaling, to orchestrating the things also from the build image. Why I mentioned that? Maybe I'm not confusing that. It's great for example, QA or integration testing. We could also use the Kubernetes cluster and nodes, for example, for just triggering the integration tests for microservices. So we don't have to have this, fixed and all the time active, because it's, it is not relevant, and it's not, we just spend the resources there. What we could do, we could apply and create the deployment throughout our Azure DevOps cycle. So you set up everything, the load balancer, the pods, and everything. Maybe run some integration test, and if everything is fine, we just kill it. We just scale it down, or make some suggestions. Maybe do some load testing with the services, then scale it up, scale it down, etc., and then dispose it. And the last thing I will just mention, because there is no time, I think I spent a lot of time today. I hope you don't mind. And these are Azure Dev Spaces. What are the Dev Spaces? Dev Spaces is a great thing because they allow us to actually run and debug one of the instance of our container together with the already deployed instances. And that's great. Let's consider that we have a lot of microservices that are, let's say, in the test stage, deployed on the AKS. But we have some changes into our code, and that we don't want to, start everything in the local or doing something. And this, what is great about this, is also isolated, and it is achieved by a special URL that is actually available only for using our instances. Is actually prefixes with our name as a user, and we can use our instance of the Kubernetes container with other that are deployed, for example, on the test. And that is actually giving the boost of developer productivity. And we just can use these tools, command line ASDS, to build upon this Azure Dev Spaces in our local machine. We can also use the Visual Studio integration, it's so-called bridge to Kubernetes, to allow this great productivity tool. And let's say for the homework, for next steps, I will just mention a lot of things is going on the area of the microservices, containerization, etc. And one of the things that I'm pretty interesting about, I don't know much about that, but I'm definitely interested in service mesh, because service mesh is actually also in the area of communicating with the microservices that actually don't communicate directly, but then it's definitely very important to orchestrate everything else. It's also some of the sidecar proxy patterns paradigm that we could use. And in this also paradigm as service mesh, the Kubernetes are definitely used for orchestration of our services. Good concept, maybe good theme up for the next session. So that's about it. So I've tried to make some wrap up or round up of the themes of microservices and containerization. There are a lot of topics to cover, as you now can imagine, like Docker, containerization, Kubernetes, the offering that Azure has, like Azure Kubernetes services or Azure container registry, etc. And I use this documentation to make this session available. So that's it. Thank you for your attention, and I'm looking forward to answer your question if you have any.
Thanks, Ratko, for a great talk. We had several questions. Actually, YouTube is about 15 seconds late in case for streaming. So we had the first question was from Dimitri. Is it just a regular Docker desktop application that has all of these beautiful images, containers list, or is it a separate application?
If Dimitri meant for this one,
yes.
that is just what you anyway have to install on your machine, and that's Docker for Windows or other operating system, and it comes with the GUI, so you don't have to have anything. Just make sure that you enable Kubernetes if you want to use Kubernetes, but you don't have to use that. Just you can use the Docker, and everything is provided by you by default.
And the image and container list is in there, right?
Yes.
Run containers. Yeah. Okay. That's the one he asked for. Yeah. Okay. And Zamir just commented on one of your statements that using microservices is not necessary for containerization, and that's basically something that he wanted to understand from a long time. Yeah.
Yes, that's something that these terms are is something like, I don't know how it is, what to have some kind of picture that explain that, but just think about that. Also, microservices don't need to be made with the containerization, but then you will not do it efficiently and out to the end. And also, this is also the same thing about the containerization. So you perfectly can use containerization without any microservices paradigm. You just need to, if you want, you just can host your monolithic application, I don't know, VPN, everything what you want to be containerized, and it will be containerized in a way that you will provide. So it doesn't have to be microservices. But with these two guys, you will get the full power of everything in the especially in the distributed architecture world.
Okay. Okay, let me just start again. Also, Vadim had two questions. Does more pods mean that each pod can handle less requests per minute, or it stays the same?
No, it's just matter of the yes. It's just matter of the balancing. So if you want to put more pods that balance your request, that is usually paradigm that is usually used with the web servers, so web services that actually constantly being attacked with the clients with all sorts, then you will use more replicas on your deployment. So that's the way.
Okay, and the second question is, can we host our own container registry similar to NuGet server? And it's already been answered by Zamir, I guess, that we can use JFrog Artifactory software for that.
Yes, there are a lot of ways. If you recall this diagram, the first diagram I provided, there are a lot of containers available, and there are a lot of flavors of the same container cells as well. So, for example, you can also have the containers that are not on the net, so it's not on the cloud. You can also deploy it on premise. So then you have your own basically Docker container.
Mm-hmm. Okay, I don't see any more questions. I guess that's it. I have already written there to contact Vadim and Dmitry about JetBrains licenses, since they were the first ones to actually ask questions. So yeah, thanks once again for the great session, and hope to see you in person soon.
You are welcome. So see you guys.
Yeah. Thanks everyone. Yeah. See you.
Bye bye.